Hello, dear students. Assalamu alaikum. Today we are going to do some math. As you know that we are in the first chapter, that is the stoichiometry from your grade 11 chemistry book. And today we will perform some stoichiometric calculations based on the examples given in your book. So let's begin. So we are already done with the example 1.1 in the previous lecture. Today we will start with example 1.2 from your book. And the question states that iron can be produced from iron ore, that is Fe2O3, by reacting the ore with carbon monoxide, CO. Carbon dioxide is produced in this reaction as a byproduct. What mass of iron can be formed from 425 grams of iron ore? So you are given a question in which you have to calculate the mass of iron produced from iron ore, that is iron oxide, Fe2O3, when it is reacted with carbon monoxide. So let's see how we can solve this. So to solve this example, as you know, it's a stoichiometric calculation. So the very first thing that you need is a balanced chemical equation. So the reaction is between iron oxide and carbon monoxide, leading to the formation of iron and carbon dioxide. So first we have to balance the equation. You know that here we have two iron atoms, so you can multiply Fe with 2. There are 3 plus 1, 4 oxygens on the left hand side. Here we have only 2 oxygens, so you can multiply carbon dioxide by 2. That makes the carbon atoms 2 here, so you can multiply this carbon by 2 as well. But that makes oxygens 5 on the left hand side, while on the right hand side we have 4 oxygens. So if you multiply carbon dioxide by 3, then it makes it 6 oxygens here, and here you have 3 plus 2, 5, so you can add 1 here. So that makes it 6 oxygens, 3 carbons on the left, 3 carbons on the right, 2 irons on the left, and 2 irons on the right. So now we have a balanced chemical equation. Now let's get back to the question itself. So iron can be produced from iron ore, that is Fe2O3, by reacting the ore with carbon monoxide. Carbon dioxide is produced as a byproduct, and you are asked to calculate the mass of iron produced if we have 425 grams of iron ore. So what we are given is the mass of iron ore, that is the mass of Fe2O3, and this is equal to 425 grams. But because it's a stoichiometric calculation, and if you remember from the previous lectures, we do the calculations in terms of moles, but we don't have the moles here. We have the mass in grams. And if you remember, I had told you that you can convert moles into the number of molecules as well as the mass in grams. We have done the conversions to atoms, molecules, or ions, but I think we haven't done the conversion to mass. So how to convert mass into moles? So to convert mass into number of moles, we have a formula, that is the number of moles is equal to the mass in grams, that is the mass given divided by the molecular mass of the compound. Now this will give you the number of moles. Because we are dealing with the balanced chemical equation, so we have to do the calculations in number of moles. We can only find the amount of iron produced from the balanced chemical equation, and the data given is in grams, so we have to first convert grams into moles and then do the calculations. So the number of moles of Fe2O3 are mass in grams is equal to 425 divided by the molecular mass. Now you have to calculate the molecular mass of Fe2O3. So you know how to calculate the molecular mass, that is the sum of the atomic masses of all the atoms present. The atomic mass of iron is equal to 55.8 and that of oxygen is equal to 16. So we have two atoms of iron in iron oxide. So you can multiply this with 2 and you can multiply 16 by 3. This makes it 48 and 55.8 would be around 111.6 and oxygen is equal to 48. So you can add the two quantities and this is equal to 159.6. So 425 divided by 159.6, this is equal to, if you calculate it, this is equal to 2.66 moles of iron oxide. So we have converted the mass in grams of iron oxide into the number of moles of iron oxide. Now we have to go back to the balanced chemical equation and calculate the amount of iron that is produced. So the given data is mass of iron oxide. We have already converted the mass in grams into moles, and the number of moles available to us are 2.66 moles. Now, from the balanced chemical equation, we know that 1 mole of iron oxide produces 2 moles of iron. So 1 mole of iron oxide produces 2 moles of iron. So if we have 2.66 moles of iron oxide, it will produce 2 into 2.66 divided by 1, and this is equal to 5.32 moles of iron. But we are not required to calculate the moles. The question says what mass of iron can be formed from 425 grams of iron ore. So what we have to do now is to convert these number of moles into the mass. So applying the same formula that we used for calculating the number of moles of iron oxide, you can apply the same formula, rearranging it for the mass in grams. So mass of iron is equal to the number of moles multiplied by the atomic mass. So a number of moles are equal to 5.32 and the atomic mass is equal to 55.8, and this is equal to 297.4 grams of iron. So if you have 425 grams of iron oxide and you react it with carbon monoxide, you will get 297.4 grams of iron. So this is how you can do stoichiometric calculations for different reactions. Let's move on to the next example, that is example 1.3. So example 1.3 states that calculate the number of molecules of oxygen produced by thermal decomposition of 490 grams of potassium chlorate. So if we have 490 grams of potassium chlorate, what number of molecules of oxygens would be produced as a result? Again, to calculate the number of molecules of oxygen, we have to write the balanced chemical equation. And the equation is, because it's a thermal decomposition, so you have only one reactant, and that is potassium chlorate. And if you heat it, it will be decomposed into potassium chloride, and oxygen will be released as a result. Because we have three oxygens here and only two oxygens here, the only thing that can balance it is that if we multiply this with 2 and multiply this with 3, that makes it 6 oxygens on the left and right hand side. But then it unbalances the potassium and chlorine atoms. So we have two potassium and two chlorines here. We have one potassium and one chlorine here. So you can just multiply KCl with 2. So that makes it a balanced chemical equation. So now you know that 2 moles of potassium chlorate decomposes to give 2 moles of potassium chloride and 3 moles of oxygen molecules. So the given data is the amount of potassium chloride, and that is equal to 490 grams. So first you have to convert 490 grams into the number of moles. Yes, so number of moles of potassium chlorate is equal to the mass in grams, that is 490, divided by the molecular mass. And you can calculate the molecular mass by adding the atomic masses of potassium, chlorine, and oxygens. So potassium is equal to 39, chlorine is equal to 35.5, and oxygen is equal to 16. And because we have three oxygens, you can multiply this with 3. This is equal to 48. And when you add them up, this becomes 122.5. You can do it yourself just to check. So 490 divided by 122.5 is equal to 4 moles. So we have 4 moles of potassium chlorate, and through thermal decomposition, it will give potassium chloride and oxygens. Now, from the balanced chemical equation, we know that 2 moles of potassium chlorate produce 3 moles of oxygen. So 2 moles of potassium chlorate produce 3 moles of oxygen. But what we are given is 4 moles of potassium chlorate. So 4 moles of potassium chlorate will produce 3 into 4 divided by 2 is equal to 6 moles of oxygen. We have already done the conversion of moles into number of molecules. So you can use the Avogadro's number to convert the number of moles into the number of molecules. So to convert the number of moles into the number of molecules, we know that 1 mole of any substance contains Avogadro number of molecules. So 1 mole of oxygen is equal to 6.023 into 10 raised to the power 23 molecules of oxygen. But now you know that we have 6 moles of oxygen. So 6 moles of oxygen would be equal to 6 into 6.023 into 10 raised to the power 23 molecules of oxygen. And if you calculate it, this is equal to 3.612 into 10 raised to the power 24 molecules of oxygen. So we, in the first example, we converted mass into moles, and here we converted moles into the number of molecules. Let's move on to the next example, that is example 1.4. So example 1.4 states that 20 grams of sulfuric acid on dissolving in water ionizes completely, calculate A. The number of sulfuric acid molecules, B. The number of H plus and sulfate ions, C. The mass of individual ion. So we are dealing with a reaction in which sulfuric acid decomposes completely or ionizes completely in water. So first we have to write the balanced chemical equation. So we have sulfuric acid and it completely ionizes into hydrogen ions and sulfate anions. And because we have two hydrogens here, so you can just multiply H with 2, and now we have a balanced chemical equation. The given data is the mass of sulfuric acid, and that is equal to 20 grams. Because we're doing stoichiometric calculations, so again we have to convert the mass in grams into the number of moles. So moles of sulfuric acid is equal to the mass in grams, 20 divided by the molar mass, and that is equal to 98, and this is equal to 0.204 moles. So this is what we are given. Now we have to come to the question and calculate or determine or answer the three parts. Part A says you have to calculate the number of sulfuric acid molecules given. So you're given 20 grams of sulfuric acid, and that is equal to 0.204 moles. And you already know how to convert moles into number of molecules. So 1 mole of sulfuric acid is equal to 6.023 into 10 raised to power 23 molecules of sulfuric acid. But if we have 0.204 moles of sulfuric acid, this will be equal to 0.204 into Avogadro's number, and this is equal to, if you calculate it, this is equal to 1.228 into 10 raised to power 23 molecules. So you can convert grams into the number of moles first, and then you can convert the number of moles into the number of molecules, or you can calculate the number of molecules from the moles, right? Now let's go to the second part, and that is to calculate the number of hydrogen ions and sulfate ions produced as a result. Remember, you are going to determine the number of ions that are produced. So again, that deals with Avogadro's number, right? So you already know that 1 mole of sulfuric acid produces 2 moles of hydrogen ions and 1 mole of sulfate anions. Or you can say that 1 molecule of sulfuric acid produces 2 hydrogen ions, and 1 molecule of sulfuric acid produces 1 sulfate anion. So how many number of molecules we have of the sulfuric acid? You already have the number, that is 1.228 into 10 raised to power 23 molecules. And from the balanced chemical equation, now we will calculate the number of ions that are produced. So let's solve part B, that is to calculate the hydrogen ions and sulfate ions produced as a result. So from part A, we already know that the number of molecules of sulfuric acid we have in hand are 1.228 into 10 raised to power 23. So from the balanced chemical equation, we know that one molecule of sulfuric acid produces two hydrogen ions. So 1.228 into 10 raised to power 23 molecules of sulfuric acid will produce 2 into 1.228 into 10 raised to power 23 ions, and that is equal to 2.5 into 10 raised to power 23 hydrogen ions. So if one molecule produces two ions, then 1.228 into 10 to the power 23 will produce obviously double the number of ions. But for sulfate, you can see that one molecule of sulfuric acid produces one sulfate anion. So 1.228 into 10 to the power 23 molecules will produce the same number of sulfate anions. That is equal to the number of sulfuric acid molecules, right? Let's move on to the third part, that is part C, and that is to calculate the mass of the individual ions that are produced as a result. So we have to take the number of ions and then multiply it with the molar mass of the ion and then divide it by the Avogadro's number. That will give you the mass of the ion. So what we have to calculate in part C is the mass of the individual ions that are produced, that is hydrogen ions and sulfate anions. So you can calculate mass from the number of moles, but we don't have the number of moles. In fact, we have the number of ions. And you already know how to convert the number of ions into moles. Yes. So we have the number of hydrogen ions, that is equal to, we just calculated, that is equal to 2.5 into 10 raised to power 23 ions. If you want to convert these number of ions into moles, what you need to do? You already know from previous sessions that if you want to calculate the number of ions, you just multiply the number of moles with Avogadro's number. 1 mole is equal to 6.023 to 10 raised to power 23. That is multiplication of 1 with the Avogadro's number. If you have 2 moles, then you multiply it with 2. If you have 3 moles, you multiply it with 3. If you want to calculate number of moles, then of course you have to divide the number of ions by the Avogadro's number. So this is equal to 2.5 into 10 raised to power 23 divided by 6.023 into 10 raised to power 23, and this will give you 0.415 moles of hydrogen ions. And now you know how to convert the number of moles into the mass in grams. So mass in grams is equal to moles multiplied by molar mass, and this is equal to 0.415 into 1.008, that is the atomic mass of hydrogen, and so this is equal to 0.415 grams. So 0.41 grams of hydrogen ions would be produced as a result. If you want to calculate the mass of the sulfate ions, so the number of sulfate ions is equal to how much? Yes, that is 1.228 into 10 raised to power 23 ions. If you want to convert the number of sulfate ions into moles, so you have to divide the number of ions by Avogadro's number. So 1.228 in 10 to the power 23 is equal divided by 6.023 into 10 to the power 23. This is equal to 0.203 moles. And now you have to convert the number of moles into grams. So mass in grams is equal to the number of moles, that is 0.203 multiplied by the molar mass, that is equal to 96. This is equal to 19.57 or 19.6 grams. So if you have 20 grams of sulfuric acid, that is 1.228 into 10 to the power 23 molecules of sulfuric acid, you will get the same number of sulfate ions and double the number of hydrogen ions, and then you can convert the number of ions into number of moles, and then from moles you can calculate the mass in grams. So this is how you can do the stoichiometric calculations. We're done for today. Thank you so much, and I'll join you in the next session with another topic and maybe an example or two related to that. So thank you so much for now. See you later.